Hello. In this video, I will try to implement the SAHI hyperinference, what a name, from the paper Slicing Aided Hyperinference and Fine-Tuning for Small Object Detection. The idea is basically we have an object detection model, and we try to detect a small object by doing inference in small patches of the images and then doing a maximum suppression of the resulting building box detected. So basically, we are using the article. This is from people from the university in Turkey. Kagatayakion, Sinar Onur Altinuk, Yalkekin Temitsel. I of course pronounce it very wrong, but this is the article. See, I think they have a library also where they implemented this, but we are going to try to implement it ourselves. Exactly this one. So as they say here, basically what we want to do is we have an original image. We slice it into overlapping patches. Then we predict for every overlapping patches at the end with rescaling using the preserving the aspect ratio. Then we can actually do the inference with the whole image if we want, and then we merge the complete set of results using non-maximum suppression. Okay, so then there is some threshold here for determining when is which boxes to remove, and there is some confidence threshold also used. What I've done is creating a small notebook with a pre-trained model. Is everything in board? Probably yes. We have an example image. We just predict with our pre-trained model. We are using Keras CV and predicting. So the idea will be create a function capable of dividing this image in patches, calling the model, and then combine the results. So maybe we can start. So the idea will be having something like that, probably with a lot of more parameters, but okay, let's start with SAHI predict. We are going to reserve for now an image. We will see later. I'm creating everything in the init file. Okay, for now it's okay. We can change it later. And the model. We are going to receive just a model. It's going to be TF, I guess. Where is our model? Retrain model. If I write type in here. Okay, so no. So at least we are going to have a model with the predict function. Maybe we can assert it later that the model should have the predict function. So, okay. So basically what we need to do is split image in windows. We are going to have here the patches, and probably these patches will have not only the image, the sliced image, but also the coordinate of where this patch starts, basically. So this should be image plus patch coordinates with respect to the original image, basically. Then we have to predict for each patch. It will be useful. Maybe you can do it like batch, like calling for all of the images. So something like model predict patches. We are going to have here our binding boxes, and then we should remap the binding boxes to the original coordinates. It's suggesting me names, let's see later. And then merging, maybe we can call it the maximum suppression. Yes. So more or less this is going to be the structure. Let's see how we can implement it. So let's start with splitting the image in windows. So here also it should be some resizing in the middle, probably. Maybe you can resizing the image just for the inference, matching the required image size for the model. Okay, let's see. Okay, then the split image, we have a lot of parameters probably. So we need window size. We can create or batch size. We can say this is a tuple in int, and when we can have the overlapping proportion like a tuple of float. Okay, I don't know what Copilot just did. Let's from typing import tuple. We have we should compute which is going to be our stride considering our overlapping proportion. So share with this stride x will be the patch size 0. Okay, should I use this 0 or different variables? Okay, so we have the batch size 0 times the overlapping proportion. If we set 50%, it's going to use 250 pixels, etc. So that is clear. Then we can do something like this, exactly going from 0 to the height using the straight y. And with the straight, are we missing some piece of the image here? What happened with the last piece of the image in here? If I have, let's just test it quickly. We have h is 300, width is 300, stride y is a really strange number like 73. I would like to have basically let's create a big tuple, something like this. Okay, something like this. I don't have the patch size, but we can create one. Okay, let's create a patch size. So I need some number, not okay, let's put something like this, and stride as we were computing it, int no, on the stride let's do something like this, and we have an overlap of 50%. And so we patches. You're right. Okay, what do we have in here? First of all, how many do we have? maybe we can actually plot it. So this is the keeping, so this is going in y direction, this is going into y direction, this is rows and columns, keeping the row fixed, moving to the columns until 138. So we are moving way, so the last patch is really small, but okay. And so probably we need just some clipping in there in the values. That is reasonable. Okay. So this always be the case, then we because this is going to be at least until 292, because it's okay. See, that is right. We have if it fits exactly with the patch size, will be at the end of the image when we make the plus. So the stride will be always equal or less than the patch size. We need to assert that at the beginning. In this case, a stride will finish at some point in here less than the difference between the last point and this one will be less or equal than the stride. The patch size will be bigger, so we will cover the whole image. Yes, I think it makes sense. Try to convince myself. Oh no, I deleted everything. What wasn't useful? No. Okay. Doesn't matter. Okay. So we need. So the start will be inside the image, not the end. So we have rows start y, rows end equal the mean between this thing and h, calls start j, mean exactly. But I would like to have not only the patch but also this information. So maybe but I would like also all the image like contiguous in memory for doing the batch prediction at the end. Okay, let's try like this, then we will see. Image patch, we have something like this, x and y. We have, let's put it more explicitly, starting row, starting column, let's create something like this. And we return patches. Have some edit from typing import list. Then I will map building box to original image. So I would like to have, so let's let's create a function. Do I need something else in here? No, probably not, because then I don't original image, patch size of each patch, overlapping proportion. Let's put some assert, overlapping proportion, exactly. Or maybe we can do if so no. But something, put some value negative will be work also. Exactly. Okay. And one thing I would like to do is just map building box to original image. So let's just receive building box. This will be an array of 4 numbers. Let's receive a patch, and let's receive the original image. Do I need the original image size? For clipping the building box, probably, eh? I don't know what this thing did. So we have H ratio, Y ratio. So the but at some point I will rescale the image when predicting. So there are 2 conversions at least. Okay, let's start. So it will be the building box in format XY WA. This is the format, no? The XY, YX, XY, exactly. We have this format. So white and height will be like this. So we will have exactly, but then I need to return exactly. Okay. Oh, Copilot is on fire. So we have I saw a Twitter meme the other day. Just my job right now is just pressing tab. That was pretty accurate. Then, so we have here the building box. We just increase the X and Y basically. Maybe we can do this more. We can create just a column with X and Y and sum for all of the building boxes. But and then we need. So we have to split this thing like this. And then I need to rescale the images, preserving the aspect ratio. So in that case, okay, let's try. Maybe we can create a method on, let's see, image path. Let's create a function, then we'll see. And then let's create patches. So we have just one. Let's create for one. So I need, first of all, not this. This is a way in build for rescaling, preserving the aspect ratio. If not, we have to do it aspect ratio. Maybe we have to do it by hand. Thumbnail method. I can compute the minimum of the aspect ratio. I'm computing the size. Aspect ratio. Can we do? I don't know. Can we do something like? You have the image. We have the minimum of something like this, but concrete target size, it will be the original image with our computing aspect ratio as the minimum of both. So we have the image, the original size. We compute which aspect ratio to use. We do this. We can do peel resize. Peel resize. Then we can pad. Whoa. Yeah. How is the thing? Like, oh my god. Peel image.resize. So this will be from array resize. And then if I want to create, I should create a new image with the thing padded. Okay, let's spill. It's like this. You should import. How do I do it? Oh, import pillow. Import pill directly. We can actually test this thing. So, and I want to open, add margin. Okay, not bad. To make it a square, we can do something like this. So we have our image, and we can create our concrete target size. Our color will be black. How do I say black? It's just a couple of numbers. Okay, that makes completely sense. 000. and then we want to paste our original image where, so probably in the middle, right? So it will be Copilot is absolutely know what I want to do, right? So let's see if this makes sense. I think it does. Rescale patch. So we have a patch. So maybe we can actually because I need the patch. I need to modify the patch somehow. How do I then? I need to know. We have two transformations here. The one with respect to the original image, and one with respect to the rescaling. Yes, probably this is a good thing for having in the image path, because this need to modify okay, let's see if this works. Then we can move it back or as a method from the patch. So in this case, we're returning for now pill image, which is the result of rescaling the image. So maybe we can do something like this. And just for now, in the array, so this is just it's not rescaling a patch. This is just rescaling, preserving aspect ratio. We can remove this, put something like this, and then we are going to return a tuple with our image. Exactly. Let's test this thing. This is not the required target size and padding used. Let's see. Let's create just a disposable. No, disposable, not for testing. Let's import this. Let's open our image. Oh. Let's not resize anything. Let's grab a patch. Let's say okay, and then we want to rescaling, preserving our aspect ratio. Let's put it some square, 500. This is going to give an error. Is the name correctly? Is the name correct? I think it is. Which was the error? I didn't see. In size, target size, but target size is now a tuple. So reload your pine. You're never going to remember how on earth. Okay. random. Okay, let's a disaster. Okay, okay, there is something inverted there. Okay, that's good. So we have image shape 2, target size, concrete target size. This is okay. Target size. There's something transposed in here. So I'm expecting what I'm expecting here exactly. 500 in the columns direction is going to be a bit bigger. Okay, scaling y until scaling y a little bit. So okay, and then padded, but the padded is reverse, and also this is reverse. What is the resize concrete size? This should be inverted. This will be 0 and okay, get a bit better. 500 by 500 is the same image. So now we have okay, so I have we have 400 columns, 500 rows. So when we numbers of rows, number of columns, defaults to nothing. Number of columns. So we have the aspect ratio. This is okay because I don't care. So I don't care the order because it's the mean. But here is important. We have number of rows first, number of columns second. But then we have in the top target size 1 is number of rows. Concrete target size 1 target size okay, it's always, but when I do the shape in here, this is rows and this is columns. Okay, so this is inverted. So we okay, in this, no, let's put this number rows, number columns, origin and rows, origin and columns. No, this is okay, and rows and columns. So we have target and rows, target and columns. Rows over rows, rows over rows, columns over columns. Please don't confuse me. So now we have our origin, number of rows with 4 times the aspect ratio, our origin, and we have concrete target size. Okay, rows and columns. This is a bit more clear. Target size of 0. So now we have concrete target size of 0 is rows, in target size of 0 is rows. So that's why this is left and on top. This is the left, but there is something I don't understand in here. It should be top, left, paste, and below paste. X and Y. So how much do I want the padding in the left? But this is going to give me a wrong result. Of course. Wait, what happened here? So we have what happened? Origin rows, origin columns. Oh no. Rows, columns is okay. Target size. We said we want 400 rows, 500 columns. This is inverted. Bill resize. But why is gigs for gigs? What is the official documentation? Resize, size, tuple, width, height. Okay, so this is width and height. Thank you very much. Oh, what the hell? And then when I'm pasting it, this is doing this disaster. But okay, let me print the top and the left. Minus 50. So we have target size of so no, then let's do with height as in the resizing, otherwise I'm confusing everything. And now yes, this is 1 0 1 0. This should probably work. So let's put we have, but it haven't rescaled anything. It's the same size. Oh my god. I'm really an idiot, eh? But now this is columns. Oh. Because it's width and height. Okay, for the love of God. So we have 500 columns, 400 in height. This is 400, 500. This is being scaled, and I have a padding of 137 on top and 0 in the left. Okay. Okay, no? If I print it right now, like left on top, I think it's okay. Exactly. We have 0 on left, 137 on top. Okay, finally. So we have this rescaling, but probably that what I was saying is that I need to know in the patch these two things. So when I predict, first of all, I know because I need to remove the padding, so I need to know that building box in which part of the original patch it is, and then in the patch in which part of the original image it is. So maybe we can do something like this. Paste self. Let's put rescale, preserving aspect ratio, target size, and I scale it left and top. This is self.image. Self.image, and I would like to have self target image. Should I so now it's a method from this, and then maybe the patch can have a map to image, original image coordinates, something like this. So we can do for patching patch, which was the size 416. This should be a parameter here, so we need model. So let's start with the parameters. There are 1,000 parameters. We need our patch size, overlapping proportion, model, image size. For now this is okay. No, yes, go. Patch size, overlapping proportion. Something like this, and then I would like to have mp.concatenate but I would like to have np span beams can we test this? We have SAHI predict, we have our model, we have our image, and then we can use our SAHI config. Completely no, we have this thing. We can say something like this with an overlapping proportion of 0.5, 0.5. and we have our 416, 416. The probability of this working is almost 0, but let's see if we can have an answer. Cannot import SAHI config from SAHI because you don't have the reload. Let's put this in here, restart and run. Okay, see, this is sorry, data class. Image has not attribute shape because this is an image. We have image path. Split image in Windows. So this is okay, because but I know this is not. Okay, and we have something. There's a print somehow. Somewhere is a print. What is a print? Remove this. The 1000 aspect ratios. And we have our predictions for each of them. Each predictions for each of our binding boxes. Okay, from boxes you have 9. How many patches do we have? Nine patches. Okay, if I overlap in proportion 0.2, we have a lot of more patches. Can I first of all, prediction. Point to predict. Okay. What I want to do is just, if this is possible, to make batch size in here. Probably not, no? Len. What is the len of this? Just a big batch. Maybe we can, if there are a lot of batches, of course they're going to enter in the GPU, but okay. So now we have a huge set of predictions. Boxes. We're going to have, this is just an array, or this is a list? Okay, we have 49, 104. So we have 49 patches, 100 boxes, with 4 coordinates. And we have also, what else we have? Keys, boxes, confidence, classes, and num detections. What I would like to do initially, at least. What is going on? Without taking into consideration the classes. Okay. Without taking into consideration the classes, we can do the non-maximum suppression. But we have, okay, this is okay. We should filter probably, right? The 64, 68. Because in this case we don't actually care about. I'm thinking in case we want to do it 2 images at a time, for example, but it doesn't make any sense because you have to split it. So I think in some point we have to flatten this thing. I don't care about the 49 boxes at the end. For me, it's but I have to map them to the right size. So yes, first I need to map the boxes. So we have boxes, confidence, classes, num detections. The first thing to do, I think, is filtering out in here no, but this is no, because this is one for each of the boxes or each of the batches. We can do, maybe let's see if we can do. We have n patches for e range and patches. I don't know what this is. Okay, and we have our number of detections. It's okay. We filter the boxes that we want to use. Then we can do map between boxes. So maybe we can do map between boxes. Let's go to original image coordinates. So we have, there are two things here. We have a binding box predicting in a rescaled image. So if we are here and we detected a binding box in here, I should remove the padding. So because if I find something in the 150 row here, for me it's near the 0 here, so I have to remove my Y padding basically. Then maybe I can make the clipping at the final end. So I think this is remove this padding, but then I have to add, and there is something related to the size that so I have to rescale the width and height. So I need to save this probably. I need to know my original size of the patch at some point. So from which number did I multiply our image? So there are two transformations: removing the padding, rescaling, and then displacing the image. It's enough, just the aspect ratio. So I have 320 pixels. I multiply by 0.042, and I have a number of pixels. It's just 1 over this number, and I got the image back. I think it's right, no? I have in this case I will have 100, no. This number is my aspect ratio, so we have 100 times this. I ended up with probably this is 125, I guess. And if I multiply 400 by this, we have 500. So if I have 500 and I multiply by this, I end up with this. If I have 125, I ended up with 100. So maybe it's just a matter of a scaling factor 1 at the beginning. Scaling factor is the aspect ratio. So at this point I should rename it probably here, scaling factor. So I will need, so I remove the padding. Wait. I've removed the padding, but if I have to rescale probably everything, because if I have something, if I have, okay, let's see see anything. If I have something like this, if I had something like this, and I do I don't remember them. If I rescaled everything for a proportion of, because it was a pixel 1, I move it to the pixel 200, I should rescale. I think I should do a self-scaling factor. Maybe we can do something like this. I think this makes sense. And then at the end, adding the patch direction, the patch position in the image. Can we just maybe we this is, I'm going to modify. Let's return a dictionary, new dictionary for now. Something like this. Let's see what happened in here. 49 patches. I would like to have, yes, let's flatten this. Let's flatten this. We have predictions. Boxes, reshape, no, yes, yes, we have 100, okay, we have, let's see, bazillion predictions, predictions, confidence, come on, come on, the same, and classes, no, it should be in classes. Oh, I hate using 1,000 keywords in my life. Classes, reshape, -1. Okay, let's flatten all this. That we can call boxes. Confidence. Classes, we'll remove the shape, non-detection for now, okay. Now we have this, we have 1,000 predictions, we have, oh my god, we have boxes, shape, excellent. And if we put this, it's going to be chaos. Oh, I see what's going on. Invalid index if scores What is going on? Scores. Because it's expecting. But I'm going to do it just for the plotting purposes. What are you doing? I forgot to clipping, Pandems 0. Boxes and confidence. Boxes, confidence, and classes, but I don't use it classes for now. That is exactly the same. No, there are a few more, but not that more. But we have the confidence threshold. But I guess no, I'm using this prediction, right? I'm not confused. So show prediction. So I guess the mapping, remapping, and hypermapping, it's working. We are missing now the non-maximum suppression to avoid having 1,000 boxes. But it's really similar to the other one, right? We have image predicted boxes. Maybe the patch size is too big or too small. Let's put but okay, I wanted to confirm that the mapping is working, and I think it is, otherwise it's too much of a coincidence. Oh, okay. 400 by times 4. How much is a car in here? Oof. A lot of patches. Oh wow. Oof. Here we can actually put a batch size as a parameter. (64 by 64 is something like this. No, it's not that small. Ooh. And I can't see anything. Why I can't see anything? What is the confidence? Everything -1. Maybe there is something wrong, 128 is something like this. Greater than 0. Oh, what's going on? I have 1,000. No. Okay, wait. No, let me add a new. don't use the num detection. Num detection will be wait, what happened? Why 4? Prediction len predicted boxes. No, predicted, oh my god, predicted boxes to boxes. But now it's going to give me an error. Put it is here. I'm expecting 1,000 predictions. Okay. 1. What on earth are you talking about? Prediction? Because it's taking me the first dimension. Oh my fucking god. Shape of 1. Please iterate over the complete set. Ah, that's what I wanted to see. Okay. Okay. It's doing something. There isn't a huge difference, but let's see when we. Okay, see there are more predictions. What happened if I put 64 in here? We have 169. So now this only step missing is the non-maximum suppression, that we can do it maybe globally or by classes. For now, okay, the prediction should be batch size parameter or something like that. We should have it. Oh, I detected the small ones at the back. And here is something happening. How can we check that our binding boxes are correct? What happens if we put because in these cases maybe it's not a complete car inside the image. What happened in here? So I will create it, then we need to create a test at least to see if everything is working. Okay. Let's try to create some tests before going forward. So let's suppose we have image this size. We have what thing we can test in here. Okay, let's first try to. So this is PV mapping. Let's try to create the test split image. Let's import this. We have image have our image, we have this one. One thing also is missing is predicting with the whole image. I'm thinking out loud, but so let's suppose we have 100 by 100, an overlapping proportion of, let's put an overlapping proportion of 0. We should have 8 times 6. Is that okay? Let's see, patches, a third, then the patches 6 times 8. Oh, for the 48. Ah, okay. Oh, let's clear UV add depth by test. Will be run by test. Okay, what happened in the ranks here? Let's try it. Because if the overlapping proportion is 0, okay, that's a good thing. If the overlapping proportion is 0, our stride overlapping proportion is 0. What is going on here? It should be, if the overlapping, okay, this is wrong, no? If the overlapping proportion is 0.3, 30%, that means I should advance 70%. So this should be 1 minus 0, right? 1 minus 0. This should, but we can have overlapping proportion of 1. Otherwise, we cannot move forward. So we should have at least something not overlapped. Yeah. Okay, that is clear. That it's okay. Okay, we have our 48. And let's try another one. If we have this with the 50% of overlapping, we should have the double, almost the double. So we have, for I think it should be 2 times 6 minus 1, because the last one is not going to enter fully. No, we have 1, 2, 3, 4, 5, 6, and we do the first one, then we do like this, and then we do like this. Yeah. I just put a random number here. Let's see. -1. -1. It's going to fail. 192. 192. It's exactly double, so we are not missing a piece. Wait, that's 2. Okay, we have 2 for the first one, 2 for the second one. We are in the last part. Okay, see, okay, it makes sense. Let's do 1, 2, 3. We have the first, the second one, the third one. We have 1, 2, 3, 4, 5, 6, but we're still not at the end. Ah, I see. Okay, we are at the end. We have the first one ends here. We move 1, and here we move 2, 3, 4. We're at the column 8, and here also the column 8. 2. We have 2. We move. We have 2. We move 1. One, 2, 3, 4, 5. Well, we have one more here. 1, 2, 3, 4, 5, 6. I guess this should be the -1 I was thinking in the past. So this is called 7. Let's see. Maybe I was right at the beginning. 1, I move 2, 3, 4, 5. Let's see. I want to take a look in here. If I have, so this is going to be at the end 50, right? Because we are this should be super easy, but let's put 600. If I do like this, but the last one will be shorter. The last one will be shorter. The first one is complete. The last one will be a bit shorter. God, the last one will be short. So one. I say 1, 2. Okay, yes, we have 1, 2. 1, 2 here. But at some point I need to cover but the last part is already, we are predicting 2 times in here because we have, in this case, okay, but yes, okay, in the last part is the last part. We're going to live with that. Okay, yes. 6 times 2 times 8 times 2. One thing I want to just measure is if I put 0.7, the greater the overlapping, the greater the number of patches, right? We can make a test for guessing the correct number of patches, but okay, it's just 2/4. We can live with it. And then we have, okay, let's suppose a split is working. Maybe we can put like this. Let's test. This should be if I put 25% overlap, this means I have 50, 25, this means it's with no overlapping 6 times 8. If I increase the overlapping, this should be more, but it won't be double, because double would be 50. It's like from which number we are multiplying here? Oh, today I'm completely brain dead. 88. So I'm trusting more the code than myself. 88. So wait, let's think a little bit about this. We have 6 times 8. If we multiply by 2, this is like multiplying by because if I put here 75, it's like multiplying by 4. It's 88. 108. But maybe we can do something like this. 88 over 6 times 8, 1.83. It's almost 1. I was expecting a round number, 0.25 overlapping proportion, but we are displacing 25 pixels. No, we are displacing. Okay, let's try it. First of all, let's try if this is okay. Times 2 times 4 times 4. This is okay. This is okay. Maybe I can leave it like this, and I can leave it like this. I can think later. Okay, this is working. So, and then we have binding box. So in this case, I would like to have, okay, I have an image size of this thing. I have a patch size of this thing. I have a target image size of this thing, let's say. So, and I have a binding box in the position 75, 8, 20, 25, X, Y. The binding box, the original position of the binding box, or a predicted position. This is our predicted position. So in which location is this? And I have also our patch position is let's say, even I can put something random, 90, 85. So I have this patch position. and we have this predicted binding box in our resized image of a patch which is 100 by 100. So first of all, I need to scale. So we have, let's put some numbers, 20, 27 and 30. So we can actually, so we have our patch size, we increase it by 3. So if the position is 6, it should be scaled by 3 because it should be rescaled, because we have a bigger image. And then we have to we don't test the padding with this thing. In our case, let's put then 80. We're 180, no? We have we are going to scale it by 3 nevertheless. We're going to scale it by, okay, let's see. We have then match. We are using this thing at the end. No, we are not using this thing. So I'm going to remove it. This is here. It's a method of image patch. Okay, perfect. So this is a method of image patch. We can image path, image patch. It's this thing. I'm going to import it. What do we need? The image. I'm going to say image size with the asterisk. No, this is just a batch, so we are going to use batch size. The position is you have a starting row and starting call. Let's patch position call, patch position row in here, patch position row is going to be 29, patch position call would be 13. Let's put some random numbers at least to make it more difficult. And then we have image patch, map binding box to the original coordinates, mp expandings, image patch, and then I need to do image patch punto rescale using this target size. But then how do I the starting row and this is my relation with the original image. This is my relation with the original image. And then and then I have the map it mini box. What are we expecting here? We need let me think a little bit. So we have the first is going to be we have this mini box. The scaling ratio, I guess, is 3 because we are doing, this is our scaling factor. Let's increase a little bit. We run in Python. Our target image rows is 300. Our origin image rows. Our origin image rows in this case will be 80. Am I right? And then we have 300, 100. Exactly, our minimum value will be 3. So we have 6 divided by 3. We have 3 as the index plus, this is x plus 13, I guess. 6 divided by 3. The other one is 29 plus 3 divided by 3. And the other one would be just like, because we are not, there is some padding in here. There is some padding in here. So this should not work, because we are not considering the padding when we rescale the image. So okay, let's maybe we can do something like assert image patch. This will be a padding in what direction? In the y direction. So greater than 0. No. What happened? Target image size. This cannot okay, let's put let's type something like this. Assert 0 is we have image (100 columns, 80 rows times 3). That is okay. We are going to scale it columns. Why is not more scale left? Why? Oh. Rename, rescale it top, rescale it left. So let's assert image path scaling factor equal 3. Oh, let's approx 3. No. Assert. I want this thing. What happened? What I think I don't understand is why. What way? Can they put float 32? Maybe I can divide it. Between 1 and 0. It doesn't lie and handle this data type. Maybe scaling factor. Because these are okay. Let's put something like this, like this, like this, like this. This is box. Okay, let's remove this float in here. So one thing I want, why is the left not the top? Rescaling, preserving aspect ratio. Origin number rows. These are the column. What it says I choose in here? What is the size I choose? Okay, I have a numpy, right? So this is my column. Okay, this is okay. So the padding should be left because this is my number of rows. This is my number of rows. This is my number of columns. Oh, I hate this inversion in my mind. Okay. So if we run it, we have our X should be failing because we need a padding which should be, we have 80 times 3. How much is 80 times 3? 80 times is 240. 300 minus this over 2 is 30. So this should be 13 plus 30 plus 6 minus 3. 5. What do you mean by 5? Predicted minimum. Why is 5? Maybe. What do you mean by 5? Right? Value error. 5, 39, 10. Okay, no, this is the padding. The padding should be removed from here. But then I have negative number. We have, let's see. So we have, okay. Let's put some real building box. Why do I don't have a negative number in there? I should have a negative number in there. Because I'm removing this. But then I add the starting column. But my starting column is 13. X, this is column X, Okay, let's see first of all the rescan left. We saw it was 80 times 3. Let's do everything again. Ruby run IPython. 80 times 3, 300 minus 60 divided by 2, 30. This is 30. Let's start by trying to understand if this is 30 or not. It is 30. So we have predicting number but we, because this is scaling, this is 6 minus our, this is 6 minus our padding divided by 3 plus 13. This is, in every case I should remove the padding. This is about the weight, but wait, the weight, the width should be kept as is, exactly. The width should be just rescale. But wait, I know what to put here. I have 3 minus 13. No, this is no padding divided by 3. This is going to be 1 plus 29, exactly 30. And then we have, this is 3. The width and height should be scale. I don't care about the padding, I just care about the scaling of the image. Okay, see. Okay. We have these 2 tests at least. Now, we need the prediction with the whole image. So maybe we can concatenate also here the prediction with the whole image for the big objects like the paper, or maybe we can make this optional. I should resize it to the model image size. How should I rescale? Okay, wait a moment. One thing at a time. Git status, git diff. Let's test and git diff by project. Function for testing. Mapping diff. Git add minus p. Yes. No. What is this? This is the lock. name is palette field diff. What is this file in it? Yes, yes, no, no. Image splitting. Git editor. Proportion issues. The overlapping proportion should indicate how much of the next batch is overlapped with respect to the previous one. Greater the value and lower the displacement. So the stride should be calculated as 1 minus overlapping. So overlapping times size. They have 90%. I should advance on it. Makes sense. The diff git add and then I can make also the other part. Git diff. This is the log, no? Git add update of the log with PyTest. Okay, then I can push it later. So now there are two more things, three things they're missing. Predicting with the whole image, make it completely independent of the library. I don't want to have TensorFlow as a dependency or anything, so just peel. So maybe instead of here of the model, I will receive a callback in which I receive the image and probably the batch size, and that's it. But I don't know, numpy will be a dependence. And then I can make an option here, use whole image as a bool. By default true, why not? Then we can image list image. Then we can refactor this a little bit. If config use whole image, but I need to resize it to the proper size, which I can use our maybe this is our resize and pad. Okay, let's copy. Resize and pad in the array. tick. Resize the image. We're preserving the right and padding the image. Image. Target size. Resize and pad it. So we have our image shape. Blah 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 blah. Padding. Return result. Here, return result. I need something else from here, probably yes. It's the image target size. And I need to exactly left top and the scaling factor. Float. This image padding use the scaling factor. Left top scaling factor, and then I can use the same here. I can use so this is like having a complete patch. Can I use the same patch target image? Can I use something like this patch? Exactly, can I do something like this? And then we are going to have the what thing? Okay, we're going to have the image, which is the image. I guess we are not copying it, we are just resizing it. Then predicting. Then okay, see, not bad. Yeah, we can put something like here. We split the image. We rescale the image. Okay, we split the image in patch. We rescale the patches. If we use the whole image, we use like a whole patch. So in this case, we are going to have just removing the padding and the scaling, I guess, and then concatenating the whole set of image rescale. They should be all in the same size. Predicting. Okay, why not? So what the two things missing are doing it independent of the model and the non-maximum suppression. I think it's time for implementing the non-maximum suppression globally and by classes. So la bola. Mare un pichete, voy soy su pichón. So what is missing now is the non-maximum suppression. We can maybe maximum suppression. We are going to receive our boxes, our score, and the intersection of our union threshold. But we need at some point everything flat. Okay, we are non-detections. So we can do we have the number of detections for boxes Y, but this is just a numpy array we are replacing here. So this is probably more clear like this. This isn't working. We're going to try start run all. So how I would like to filter our boxes according to the number of detections, but I have to filter also the confidence and the classes. What happened? Data class expected because I created a function and didn't put pass. Exactly. Pass. Maybe I can boxes. Image patch doesn't have attribute append because this should be patches SAHI config model image. No, model image size. Okay, we have the 49 plus the 50. Okay, well, not completely right. The other thing. Okay. So one thing I would like to see, I have this. Let's just take a look. Wait. Let's just take a look. Predictions. Okay, this is work. The indexing I was using. This is okay. Shape. Because it is just flattened. Okay, maybe we can do something like this. Maybe I can start to modularize a little bit. Prepare patches. We are going to receive a list of patches. Why do okay and the configuration. Okay, chill. This is in place. Return patches. Configuration, list of image patches prepared for the model. We have patches prepared, and this will be just predicting. And I would like to prepare patches map binding box to original image, but I should return a lot of things. This is okay. We are going to receive a dictionary. and the list of patches. Maybe I would like to create a class out of this. Let's create a data class model predictions. Exactly. And this will receive model predictions. We can do like this, we can do like this, we can do like this. Data class, okay. But and this point is okay. This class is a bit, so I can do boxes. Let me think. Because I'm thinking of the model prediction. It's at some point per patch, per binding box, but at some point we flatten and we use not per patch, but the flattened thing. So the 100 or 1000 prediction in a row, and I don't know how to create this or how to make this clear in the typing. Maybe I can say confidences classes. These are the unflattened predictions, but I don't want to have two types. One for they are exactly the same, but one flattened, one not unflattened. Maybe let's not introduce an additional type. Let's do something like this. We have number of detection. We pass here our boxes, and we have our boxes, our confidence. These two will be patch boxes, patch confidences, patch classes, and then we can. Okay, we are talking about really small. Let's go. Final boxes. Let's don't get crazy with this. And then we can return a dictionary. Number of detection will be okay. We can final number of detection 0 exactly, and return basically the same structure, but flatten. So I would like to make a reshape at the end here, not here, but here, -1, 4, -1, -1. So I don't like this function. But, so how is for now? Okay, this is okay. Let's return this. Can I have the raw thing? Predictions 3. Okay, the number is probably right. We have our boxes, and we have okay. And we plot it like this. What do we see? Probably the same thing. Okay. So we have our maps. The predicted binding boxes from patches to the original image coordinates, dictionary with 4 keys, this return a dictionary mapped binding boxes, a dictionary with 4 keys. The resulting binding boxes are the ones with a prediction. Okay, we have this. I don't like that much having to pass these dictionaries with strings, but then again, I'm not sure. No, let's create it. No, I don't like having this string floating around. Model predictions. Boxes, non-detections, confidence, classes, and let's create a model predictions with exactly this thing. Maybe we can it's okay. Not okay. We have this. Now we call at some point I have to create the model raw predictions, model prediction is this thing. This will call it here, and then we use non-maximum suppression, and we can pass everything. Why not? Non-maximum suppression. So we are going to receive our model, our predictions. Oh, we can call it building boxes. I don't think I write it correctly. Model operation. This is the way to write building boxes. Fucking English. Oh, let's use the other account. Okay, so let's apply. Okay, chill. We have boxes, we have our confidences, and we have our classes. Okay, first of all, we need to iterate, we need to filter by classes. So we're going to do for class in unique. So the how can we call this function? So basically I filter by classes, and then we maximum suppression. Okay, the name is terrible, but okay. And here we just receive our boxes as an array and our confidences. Confidence as an array, and we return what do we want to return here. What do we want to return? And the array, I'm not completely sure about what do we want to return. Maybe the indexes. So we have class boxes, class confidence. I don't care about this, and I can say, okay, which of my boxes and my confidence are the one to use. We're going to write out boxes, out confidences, append class boxes, and then out class. I need the classes also, right? I need the classes. I don't like that one. And num detections, it will be length indexes. Sorry. And then plus equals at the end, return our model prediction with everything concatenated. Concatenate out boxes, concatenate classes, concatenate. Okay. And we have our boxes and our confidence. So at some point we need confidence sort with the inverse order. So we have our indices. We have while. So let's see. Let's put out. We can get the first one. Now, if I sort it like this, I need a threshold here, right? I need the threshold. I take this one, add it to my final list. Remaining indices and the other ones. I need to compute the intersection over union of this box with respect to the other ones. This is okay, and keep the ones less or equal to the threshold. No, this is okay. We have these things sorted. We add this always with the indices. Remaining is all the remaining. Am I missing something there? I think I'm not. This will be we are computing okay, but I need to convert it to, so this is my x coordinate taking the maximum here, okay, and then the y coordinate taking the maximum in here. So we have two boxes in the left coordinate, one here and one here. We are taking this, okay, the same for this one, and the minimum, and this is okay, yes, this is my x coordinate, this is x plus width, y because it is xy, okay, yes. And then we have the x, okay, this is okay. Is that simple? I think it is, eh? We have the, you know, if the broadcasting works. Maybe it works. Can we try this? We can create a proper test. Of boxes. This is what the kids are calling vibe coding. We have our box. We have our, okay, let's put origin box, for example, and then we have boxes. We can create, for example, the same box, this box, this box, but smaller, this box but displaced, and a completely far away box, for example, something like this. What do we have here? So what do we expect? We expect 1, like 1/2, and 0. Oof. What did I write in the array? One, this intersection over the union. It's this will be okay. So this will be 1/2. Okay, 1/4, 1/2. Why this one is this value? Because the union is bigger. the intersection will be 50 by 50, because this will be 50 by 50 over plus 50 times 50. Oh, what the hell. Intersection 0.2. We have an image 0, 0, 100, 100. 0, 0, 100, 100. This is starting 50, 50. And it's 100 in width and 100 in height. So there is an overlapping of 50 in this direction, 50 in this direction. So intersection is 50 times 50. Wait, this one. What am I missing here? Let's print everything. Let's print the intersection. Let's print the union. Let's see what we have. Okay. This is 1, 2, 3, 4. Okay, this is right. But then the intersection is smaller. 0, 0, 100, 100. I'm starting 50. 50 here, 50 here. Oh, I need a pen and paper. I need a pen and a paper. So this is computing. This is a union. It will be minus the intersection. Will be minus the intersection. So it's not this, because I have to subtract. But it's not going to be this number. No, of course not. Our intersection is okay. I understand the intersection, and then we have box 2, box 3, 100, 100 plus. Wait, what did I write here? No, this is wrong. This is 100. So my weight is 100 and 100 in both cases minus the union. Okay, yes. So we have, oh my god, in both cases the area is 100 by 100 times 100 here and here, but then we have a small union in here. So we have the small intersection in here, so the union becomes this number, and then okay, it makes sense. It makes sense. So we can create let's create expected we can create 1, 0.5, 0.1. Then we have here, we said we have 50 times 50, which is our union. Minus 50 times 50, and then we can do not again. Wait. This is times 2. Okay. Times 2. Okay, let's put here in the test IO. And let's make something like this. Okay, enough. Okay, run by test. Okay, so we have our U of boxes coded by our beloved CoPython. We have non-maximum suppression, multi-class on maximum suppression. So I just have to remove this because it's going to fail. Exactly. Detection boxes. No, this is boxes. This is confidence. This is class or classes. I don't remember. Oh, come on. Race, but that's why I don't like at all these strings keys. Classes, confidence, boxes. Some in singular, some in plural. Okay. What? Confidence. Model prediction is not defined. Wait. Chill. Which error? So we are here. This is okay. Type error. Model prediction is not. It's not scriptable. Okay, this is okay. We have boxes. We have also num detection in here. we have scores. No, it's confidence. I think that's it. And what do we? How many do we have at the end? 164. Show predictions. So let's remove this, because in this case I will have every prediction will be. No, maybe we can filter it for the confidence, but okay, not bad. What happens if I put 64 in here? I have millions of. I'm trying to take a look. Maybe I can increase the. I should add the parameter of the confidence threshold. There is a lot of strange things, but this is capturing a lot of things at the background, and also here I don't know what happened. Okay, let's add a parameter here. This one, SAHI config float. Other thing I would like to add is font size will be optional. So I would like to do if know what size it's used. I will try to put everything in the working, or is just failing at some point? Type error. Okay. Don't be mean. Okay. And then we have our what's the name? Hyper inference. Okay, not that bad. So other thing I would like to do, this is at the end per classes. I think it's reasonable enough. I will have to test this for multiple classes, how it works, but I guess it's okay. I don't put here the config IOU threshold. Another thing I would like to do is making not use TensorFlow at any point. So I will remove this MP. Okay, TensorFlow. I guess it's not used anywhere, but how can I do this? How can I enforce this to be a function? So I would like to define this as a function that return this is something I can define now, no? This is not function, it's callable, something like this. Callable. How do you define this? Python typing can be annotating using collection if it's calibrated or deprecated typing cal deprecating side changing caliber no support deprecated alias how do you define the type of a thing that returns something? This is parameter list, what they return. Parameter list, what they return, and this should be from ABC, because this is going to create a chaos in dependency, right? Because in some Python let's see. So we're going to have model predict. This will be our model predict. It will receive the image, the batch size. We're going to create, just for the sake of TF, model predict batch size, and then okay, you're right, this is our model let's call it here as CV predict. This is image to predict. What size? Let's call useful function for with partial purificating, how do you say it's clear, this form using it together with punto partial to use using SAHI predict. So let's do from func tools import partial predict is equal to partial pre-trained model. How we import this? This is model prediction. We don't have any strange dependencies. We can maybe instead of image use payload image. Let's move the imports to the top, organize import here, it doesn't like, format cell, no, I don't want to have to organize it myself. Okay, from func tools, these two at the bottom, import fmn and our thing. Okay, we have the model, we use the pre-train, then it failed. No, it doesn't matter. What happened here? Run out. Let's simple implementation of, okay, let's put of SAHI. To be example, see the notebook. Come on, Copilot. Okay, then we can write it later. Okay. We have our SAHI predict. So basically, again, I have to, okay, then I will create the documentation later. So okay, it is working. We have a dependency free SAHI for predicting. We can, from PyProject, remove everything here just for the examples. Keras, so we need numpy, payload, and that's it basically. For testing, so we can have numpy greater and equal, I don't know, any numpy basically. I don't have so many requirements, to be honest. No, not documentation. I want the versions. And 1.14, I don't know. Below, I'm not sure also. Okay, for the example, you need everything basically, but is in the example. Implementation of slicing aided inference. Okay, not bad. I think it's working. I will try to improve a little bit the documentation and push everything a bit later. But at least we have a reasonable implementation with non-maximum suppression. I think in their implementation they have also non-maximum merge, and I think they group the boxes somehow, but okay, at least we have a small implementation. I will try to improve the documentation and maybe create some test for non-maximum suppression. If I find something strange, I will add something to the video later. But for the time being, I think we can close it here to the minimum per class. Set of predictions. Threshold. Maximum suppression. Binding boxes. Confidence of the binding boxes. IO threshold. And this return the indices of the boxes.